Okay, Advanced Algebra 1, Topic 9, Section 6. This is the second video in that section, and it has to do with the discriminant. The quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And sometimes when we plug in all those numbers, we end up with something like, negative 3 plus or minus the square root of 100 all over 2. And 100 is a perfect square. And so what we get is we get a rational number as our answer. Okay? Or a fraction, if you will. Okay? Or even a whole number. A whole number can be written as a fraction. Sometimes we get an answer like x equals negative 3 plus or minus the square root of 84 all over 2. And 84 is an irrational number. It's not a perfect square. And so our answer is, or are, irrational numbers. Okay? Sometimes we get x equals negative 3 plus or minus the square root of 0 all over 2. And the square root of 0 is 0. So this whole thing goes away. And we just get x equals negative 3 halves, which is rational. But we get what we call a double root. And then the next thing that can happen is we get x equals negative 3 plus or minus the square root of negative 87 all over 2. And the square root of negative 87 is not a real number. And so what we say is that when this happens, we have no real solution. If you recall, from every one of these things, what I pointed to find the nature of the root was that thing in the radical, the radicand. I've got a perfect square in here, I get a rational answer. I don't get a perfect square in here, but it's positive, I get an irrational answer. I get a 0 in there, I get a double root, which is rational. I get a negative number in there, and I get that there's no real solution. And so the discriminant, it emanates from b squared minus 4ac, because that's what I'm taking the square root of. And it indicates the nature of the root. What are the roots going to be? Am I going to get rational roots? Am I going to get irrational roots? Am I going to get a double root? Am I going to get no real root? What am I going to get? And so we set these guidelines. We say, well, when that discriminant is greater than 0, and greater than 0 here, we need to think of that in terms of greater than 0 is positive. So when the discriminant is positive, that indicates that I'm going to get two real solutions. They might be rational, they might be irrational. Okay? And that depends on whether or not that discriminant is a perfect square. If it is a perfect square, I'm going to get rational roots. If it's not a perfect square, I'm going to get irrational roots. Okay? And then we go on. If that discriminant is equal to 0, then that means we're going to get a double root. Okay, we get one real solution. We call it a double root. And when that discriminant is less than 0, and less than 0 means negative, then that indicates two conjugate complex solutions. Or we say there is no real solution. Okay? Once we get up into higher mathematics, we'll recognize that as we'll get something like 3 plus or minus 2i square root 5 over 2. And that's what those roots will look like when we learn how to simplify complex numbers. Okay? So what we want to do is we want to use that discriminant to determine the nature of the roots. We don't want to solve this thing all the way out and say, oh, here we go, here's the root. We just want to use the discriminant. So I'm going to do b squared minus 4ac So here I get 16 minus 4 times A is 1 times C is 3. I get 16 minus 12. That's going to be positive. So I get 2 real roots. Okay. This next one, I'm going to have b squared, which is 16, minus 4 times a, which is negative 1, times c, which is negative 4. I'm going to have 16, it's going to be minus 16, which is 0, which one means I'm going to get one real solution, which is a double. Okay, so we don't want to solve these. We just want to look at the discriminant and say what is my answer going to look like. All right. So let's see. Opposite of b, so 4 plus or minus 16 minus 4 times 1 times 5. Oops, what am I doing? I just said we're not going to solve these. Oh my goodness. All right, let's try that again. Okay. So b squared would be 16 minus 4 times 1 times 5, or 16 minus 20, which is negative 4. That's that is not positive 0, so that is negative. So we say we have no real solution, which doesn't describe the roots. You know, we can just say that 2 conjugate complex solutions if you want. So I don't know, in the online homework they might look for either one of those things. All right. So that's pretty much it for section